If you're paying good attention to the last video, you've learned an awful lot of information, and hopefully this will just append a little bit of extra stuff to it. It is much more important that you understand that first video than you understand this one. We're adding to it. If you don't have that down, again, particularly if you've got some time management issues going on, go back and make sure you can do what was in the last video. But we're just going to add 3 more rules and produce the total number of 10 that we're actually working with for the test, and hopefully get you a deeper understanding of what's going on with these issues. So the logical equivalences, this is in the bottom of the sheet, and the logical equivalences don't work quite like the implications. The logical equivalences can do 2 things the others can't. First of all, they go in both directions, so they can go, as it were, from the left to the right and the right to the left. You cannot do that with the implications. The other thing that's interesting about these is that you can do them in the middle of an equation. You can do them inside of parentheses, which you could not do with the other rules. The biggest headache you're going to have on the test, if you've got everything else down, is what's called DN, or double negation. We could have done this in Chapter 7, but we didn't. The way the rule looks is something like this. It's flipped around, but that doesn't matter. We have an equal sign here in logic. This is called a biconditional, if you want the technical term. But what it says is that P is equivalent to not P. And that's kind of obvious, that P would be equivalent to not P. But as we see when we work the problems, it's going to be important sometimes to add or subtract negations. Now, if I have a statement like A or B, I can do double negation adding a whole bunch of ways. I could put 2 negations in front of it. I could double negate the A. I could double negate the B. I cannot split them up. I cannot have the A on one side and the B on the other. So it would be wrong to take something like A or B and make it not A or not B. That's just not the same statement. This says one or the other is true. This says one or the other is false, and those are not logically identical statements. So the negations have to touch. I can add them anywhere I want to so long as they touch. The only place I suppose I couldn't add them is right in front of a connective, because it would mean nothing. I can also take them away, but I have to take them away in pairs. So if I have not P arrow Q, it would be wrong to take both of those away and just make it P arrow Q. They have to be touching, and here they're not touching. So if I have not A implies not B, I can make that A implies not B, and then in another step make that A implies B. I pull them away 2 at a time, or I add them 2 at a time with double negation. Now again, we could have done some double negation work in the last chapter, but it would have been meaningless. Here it's actually going to serve a purpose, and I'll get to it in a little while as to why we want to do this, other than just to clean things up. When it's just a matter of cleaning things up, it's pretty obvious what we're doing. The other 2 rules, commutation and contraposition, allow us to flip things over. So rule number 9 is commutation. And you write COMM. This is a rule you learned in math. So what does this look like in math? A plus B is the same thing as B plus A. A times B is the same thing as B times A in math. Notice that you can't do that with division. 7 divided by 3 is not the same thing as 3 divided by 7. Subtraction doesn't work this way either. But sometimes it works just to flip it around. From Chapter 6, we found that when we were working with AND statements and OR statements, it didn't really matter what order they came in. And so if I have a statement like A and B, it is logically equivalent to B and A. If I have A or B, it is logically equivalent to B or A. And I can flip those around anytime I want to, including inside of parentheses. So all I'm saying is it just doesn't matter what order they're in, but that's the rule that lets me flip them around. When you have to do that, it's going to be bookkeeping. More useful than that is contraposition. C-O-N-T-R. Now, if I have an arrow, the order does matter, and it matters a lot. So I can't just flip an arrow around or I will change the logical meaning of it. But I can take that and turn it into its reversed form if I negate both sides. So what I have to do when I'm doing the rule of contraposition is flip the Q's and the P's, flip the left and the right. And I either going this direction, add a squiggle to both sides, or if I have the resources to do this, I can drop the squiggle from both sides. So if I drop the squiggle from both sides, they both have to be there to begin with, and they're not always there. If I have something like not A implies B and I want to contrapose it, I cannot take away from both sides because there's only one side to take away from. So what I have to do is I have to add to both sides. Excuse me. Let's do that right. I have to add to both sides. There we go. So I've added to not A and made it not A. I've added to B and made it not B. Now then, if I want to, after I've done this contraposition, I can do a double negation and clean that up. But in the step, I either have to add to both sides or take away from both sides. So that allows me to flip it over. The last two rules we have on the list, implication and De Morgan's law, are kind of interesting because with both of those, I can turn arrows into ors and ors into ands. But you don't need to do that for what we're going to be going into. It's just if we were going a little bit further, it would be intriguing to be able to manipulate statements that way. So what I'm going to do is I'm going to flip to the end of the chapter, not to 8.5, which would be the appropriate, or excuse me, 8.4, which is what would reasonably next, but I'm going to do some problems from the overview, which in the book I've got in front of me is page 160, but isn't necessarily that in the version that you're going to have when you're watching these videos. So let's try a couple of different things. Problem 3. And so I'm in the overview. And notice you have to number these lines. We didn't used to have to worry about that. V or W, N is false, W implies N. This is a beautiful one for, again, what I was calling connect the dots. V is where I'm ending. V connects to W, W connects down here to line 3, to the letter N, and N is back in line 2. So V or W, N is false, W implies N. So I'm going to start with lines 2 and 3 because that's where my N is. 2 and 3. W implies N, N is false. So I have an arrow and I know the right-hand side of the arrow is false. That tells me that the left-hand side of the arrow is false by modus tollens. V or W in line 1. W is false, so remember that's an OR. There's not a lot of rules with an OR. Tells me that V is true by 1-4 disjunctive argument. And V is the conclusion I'm supposed to reach, so that's where I wanted to go. Problem 4. Let's do problem 5. H implies not C. 2. Not C. 3. H or L. Conclusion L or D. That's a nice little one for you. I need L and D. Here's L. I've got no D. The D shows up out of nowhere. That's a big hint as to what your last step is. Here's L's connected to H. H is connected to C. So I'm going to look at lines 1 and 2 because that's the beginning of the problem. That's where I have the letter C. Again, L to H, H to C. H implies C is false, but it is not the case that C is false, not C. It's an arrow, and I know that the right-hand side is false. So I now know that the left-hand side of that arrow is false by modus tollens. Again, modus ponens, modus tollens, disjunctive argument, you'd be using those a lot. H or L, not H. If that side of an or is false, whatever is left is true. L has to be true, and that's going to be 3-4 disjunctive argument. Now to finish it up, I need to get a D out of nowhere, and it's an or D, so there's only one way to pull that off. There's only one way to bring a letter into the problem that wasn't there to begin with, and that is to use the rule of addition. And I would just put the number 5 here because it's L's in line 5. Line 5 addition gives me L or D. So these two problems are actually quite similar. They don't really look like it. The big difference, instead of modus tollens disjunctive argument, is I have modus tollens disjunctive argument and then the addition to wrap it all up. Again, get in the habit of trying to do the problems all the way through, because the way that you're being quizzed on it online can sometimes be a bit of a disadvantage because it oversimplifies what you're being expected to do. I just can't consider every possible juncture as to how this might happen. Let's look at 7 then. This is kind of cute. If you remember from the first part of chapter 7, if I have a contradiction, I can prove anything. It's always a valid argument off of a contradiction. That's not nice, that's just how formal logic works. Well, how on earth am I going to make this happen? I'm told that P is true and also P is false, which are contradictions, and I'm somehow supposed to prove that Q is true. It's not actually that complicated. The first step is to figure out where I'm going to get my Q from out of nowhere. And the place I'm going to get Q from out of nowhere is the same place I get anything from out of nowhere. That is the rule called addition. So line 1 addition, I'm going to take my P and just do or Q to it just because I can. Now all I have to do is liberate the Q. P or Q, and I want to pull something out of an or statement. That's a disjunctive argument. P or Q. To make sure that the right-hand side is true, I'd have to prove that the left-hand side is false. Oh, look, I can do that in line 2. So 2-3 disjunctive argument gives me the Q. So I take P, I add Q to it with addition, and then I take it away using a disjunctive argument on 2 and 3. 2 steps is all it takes to do this. And again, you can reason it through if you remember that addition is the only way that you just pull something in out of nowhere. And once you've got it there, then you just have to figure out how to clean it up. Problem 8, there's a couple of ways to do this, so I'm going to write it down twice. Not J, sorry, I'm thinking of a different problem. We'll just do it the one way. Not J or not K, and K, not J. When you get to problem 8, you're starting to get into the exciting world of double negation. And double negation is kind of a headache some days. Because why? Because I have to think about the rule of disjunctive argument here. I need not K, not L. Let's try that again. I need not J. It's connected to not K, and it's connected by an or statement. The way I pull something out of an or statement is to use a disjunctive argument. The way that looks is I have to know that one side of these is false, and then the other is true, whatever's left over. K, though, is false, and I've not got its denial. I have got its opposite. You're going to have to trust me here that what I need to do is to say not K. In order to do that disjunctive argument, I've got to do a not K. Because the rule for a disjunctive argument says I have to have an or, and then I have to know that one side of it is false. That is whatever that side is with another negation. But I can get not K from line 2 by doing a double negation on it. Not J or not K, but not K is false, so not J is true. And that's going to be 1-3 disjunctive argument. I would suggest spending a little time meditating on problem 8 because it's only 2 steps to solve it. But you have to understand, in order to really get this chapter, why you can't just do a quick disjunctive argument and be done with it. Because I will concede, it looks like you ought to be able to do that. It just doesn't work out like that. All righty. Oh, let's see. What else will we play with? Oh, that looks beautiful. Let's look at problem 11. H or not I. Line 2. I and J implies H. Therefore, not J. Ho, ho, ho. In this cutie. Well, first thing you do, you've got an and statement. When you see an and statement, you tear it apart. I, J implies H, and I'm going to tear this apart using the rule of simplification. Always do your simplifications if you can at the beginning. J implies H implies not I. Another thing you want to look for early on is a place to do a chain argument. J to H to not I is J to not I. And that's going to be 1 for chain argument. Now what am I down to? I, J implies not I, and J is false. It's going to be happy, fun double negation time here. Probably the more obvious of the two ways to do it is this. I take the I, and to deny not I need not I. Everybody confused? Good. So I take my I here, and I make it not I. 3, double negation. And now I do that again. Not I. 6, double negation. If J is true, then not I is true, but it is not the case that not I is true. So I can now do, on lines 5 and 7, a modus tollens. I know the right-hand side of an arrow is false, so the left-hand side of the arrow is false, and that is not J, and that's the answer I'm trying to get to. Okay. This is where we're starting to go into happy, fun, tricky land. Let's back up a little bit, because if you did that and you've been watching this, we've been hitting a lot of material very quickly. So let's back up and do something that's not going to give you quite so much heartburn. Make sure you can do this, okay? Because if you can do this problem, you can solve an awful lot. This is just 2 on the overview. A to Z, B to K, K to A, B, conclusion Z. Now that kind of a problem, again, where some of the rest of this gets really elaborate, that kind of a problem is the one that you should be able to handle to get a good toehold on this whole section. There's not a lot of funny squiggles in here. No, nots. It's just an arrow, and a couple of letters. A couple of basic skills. There's 2 things you look for when you start. One's and statements, which you don't have here. The other's a whole lot of arrows. Arrow, A to Z, B to K, K to A. So if I look at all those statements and I realize there's a bunch of arrows in here, what rule does that bring to mind? And you only got 10 rules. And you got a cheat sheet. You should be looking at those and thinking chain arguments. The other trick to trying to think through a problem like this is to think backwards. Here's Z, Z goes to A goes to K goes to B is your starting point. There's 2 basic solutions to this problem. One, I'll just do it over to the side here, is just to start doing modus ponens. B is where this whole thing begins, right? The end is Z, the beginning is B. B to K, B is true, so K is true. 2, 4, modus ponens. 2, 4. Now I've got the letter K. If K is true, then A is true. Well, A is true because K is true. 3, 5, modus ponens. If A is true, then Z is true. A is true, so Z is true. 1, 6, modus ponens. If I see that answer on your test, you're good. The other is to look at this stuff and think chain arguments, and you can do a couple of chain arguments. Here is a different way to approach it. A to Z, K to A, so lines 1 and 3, chain arguments. K to A to Z is K to Z. B to K, K to Z, B to Z. 2, 5, chain argument. Now, if B is true, then Z is true. B is true, so Z is true. 4, 6, modus ponens. Okay? And there's a couple of other ways to do this, but basically you're going to be either doing a bunch of modus ponenses or some chain arguments and then wrapping it up with the modus ponens. Like I said before, you can get kind of tied up in knots on some of the stuff towards the end with all the negations and the double negations. That's great if you're trying to knock everything out of the park, which I love seeing. But ultimately, this sort of thing, you should really have your head wrapped around. So those first 4 rules, modus ponens, modus tollens, chain argument, disjunctive argument, you got to know those, and you've got to know what it looks like to do them correctly. Because the majority of tests that I see don't even have people able to do those first 4 rules on Chapter 8. Chapter 8 ends up being this kind of I surrender. Think about it. On the final test, there are 20 points. 6 of those points are problems like this. So you're going to take a substantial hit to your final grade if you're not able to do at least a chunk of that properly. And this is what it looks like to do this properly. This would be a good answer. This would be a good answer, and I could give you probably 8 other solutions that would work fine as well. You give me a solution that works well. And again, if you're a little concerned about this, you do have the rules that will be in front of you. One of the things that will be in your packet for the final is this sheet with all the logical implications and all the equivalences. And so you don't have to memorize them, but you have to know how to use them correctly. If you can use them correctly, life is going to be pretty good. So what I will tell you when you're looking at the overview at the end of the chapter is we start off fairly slow. By the time we get to 8, we're into the logical equivalences. And then towards the end, it gets pretty fancy as far as needing to use De Morgan's theorem and implication. About 18, it looks like, you start to get into that territory. No, 16, you start to get into that territory. So those last 2 rules add to the complexity quite a bit, but we're not going to be going into them. You're still free to use them if they apply to the situations that you're looking at, and I have had that happen. So if you watch this video, give it a shot, look through it, try to do these problems. Do the problems over and over again till at least the ones in the book become second nature to you. If you need to watch these videos again, please do so. If you need to go to the website and grab some of the older videos, there's some old videos up too, and you can look at that over the same material and see if any of that helps you out. Ultimately, you do have contact information for me. Again, this doesn't work very well if it's the night before the last day to take your final. If you got a couple of weeks in there and you're on your regular schedule and you're putting this together and then you just don't get it or having a particular problem or two, then I can help you out. So get a hold of me if you're having issues. I've done some of this over the phone, though I must admit, this is pretty darn tricky to do over the phone. It's a lot easier if you can come into the office for it. Okay, thank you very much, and have fun with the final then.